Welcome. This video I'm gonna teach you uh, an improved version of the Babylonian square root finding method that I created a video for. So let's open idle. Let's see if I have it. I do have it. So if we talk about, I created a program that will stop at the iteration 100, and if it is less than, if the guess of the square root less than 69, I can improve this program a lot. So let's make it, save it as a div. Call it finding a square root prove. Okay, so let's change the date. Today is the 29th. I'm gonna call it prove version. So we're gonna keep everything the same, but in this case, we're gonna have a tolerance. So that's one of the things we are adding, the tolerance constraint specified by the user. Okay, so that tolerance, I'm gonna call it tolerance tool, and I want that tolerance to be 0.02 or 1. Okay, so that's one of the first, and also so we're also gonna add something called let's see, what else can I? Okay, so that's the first thing I'm going to do. Okay, so first things first, okay, my first attempt to find the answer to the square root is if I by with the initial guess 5 times 5.5 gives me 16. I'm gonna change it a little bit. Let's put 6.5. And it shouldn't be like this, because it's basic. We're gonna do it we're gonna square our initial guess. Okay, so that's the first thing. We're gonna still output it, but we're gonna check whether the guess, we're gonna do whether absolute value of root minus s bar less than or equal to our tolerance. So basically we're taking the difference of our actual root, actual we're taking the root minus the actual minus guess value. The difference has to be less than the tolerance. So the difference between those will give me will provide me a better answer. Okay, the next step is gonna be, we're gonna, okay, so, okay, so first I need to put it, okay, then column here, also, okay, so we know that the tolerance, uh, uh, so we're within the tolerance. I'm gonna pull it less than here, because what I'm gonna do is that if it is less, that means that I can keep going. So what I'm gonna do, I'm gonna copy, I'm gonna cut this, and going to continue here. Okay, we're gonna check this here. Instead of this, keep checking each iteration. Okay, so but instead of guess bar, what I'm gonna do is okay, the but see here, I already printed the first iteration. So what I'm gonna do is going to increase I. So I is gonna be equal. Actually, let's see, we can do that different. And I don't and to be honest with you, I don't wanna check it here because I already checked it here one time, so if I check it again, it's going to agree with it, but okay. It doesn't really hurt, but it's an extra step that we need. Okay. And less than 100, we can keep this iteration like that, and this is okay. But instead here, we're gonna put or, because if either this constraint here, this tolerance, or if it reach 100, I'm gonna put less than or equal to 100. Reach 100 iteration, we're gonna stop the program. Okay, so the guess part is that increase the iteration, print it, and then go to the next. Let's see if this works. Okay, but instead of here, what we're gonna do is we're going where it again to check that. Here we did it beforehand. Here we need to do it each time we go through the loop. See what we get. Okay, find some problems. Okay, there is something going on. So my guess is that is don't forget this is tolerant. What can be wrong? I'm sure there has something basic. Take this one off. Bar. See what we're getting. Let's troubleshoot. Gonna bring this. See what we get. Take the file. 42. Okay, so 69 minus 42. Tolerant. Less than tolerant. Oh. Okay, so I know what the problem is. So when I take the minus minus, okay, so our first iteration, what we can do is this. Okay, okay, so we're doing 69 minus 40 something. That's gonna be equal to less than. So it's not gonna print. What we have to do is we're gonna keep going. Okay, then we put this here. So so we have to think the opposite way. Okay, so now, so if we don't have the tolerance, we have to keep going. So that's why we put this here. But this one we have to keep because we don't wanna go over beyond the 100th iteration. One thing to notice is that I wanna be able, because what happens if I input for my for my initial guess the actual uh, the actual answer. So I have to check. So if it is greater than the tolerance, you do that. Then you can say else, just print our guess basically. That's all we, because we are on track. Let's see what we can do. We're gonna test. So we get to 100. Okay. One thing to notice is that this the estimation, but then we have to check. Gonna add something for gonna our root, the initial This we need to add it here. Save and run. Okay. Can you put on print? Here we but we don't have to do it because here we're concatenating, so we do have to use it. Here we don't. Save. Okay, so now the initial guess was 42. Okay, so it says here root approximation 40. The actual root that delete this that part because I don't think this is right. But is so our first attempt is okay. Can instead of here guess bar we're gonna init guess where or just guess. That's our initial action. So here we're gonna guess where that will work better. Six point five 42. That's correct. Take 6.5. Okay. 21 square is this here. So where do we get to? Let's see. Correct here. See. Let's go back to our program. What happened is that we square it. So what we have to do is we have to let's put this one here. And let's get rid of this here. We don't need this one anymore. We don't need this. Of course, this iteration. Have that. And then here, what we're gonna do is we're gonna let guess bar for init guess. So we set the initial initial guess to the guess variable to the initial guess. This should work. Yes. You can see here starts at 6.5. Then we do the average and we get this one. Now we take the average of this one and the other thing. Get this one. Then this looks much better. And as you can tell by the third iteration, we're already getting very close to tolerance to our actual root. By this point, this is just this here. These are just very tiny differences between the actual value and the guess value. But like I said, I stop it at the 100th iteration. And it says here 101. Okay. That shouldn't be that big of a deal. Just printing the last. That can probably be fixed by. It is because I put this one here. Instead of putting it here, what I'm gonna do is I'm gonna put it here. But if I do that, then I have to because I did one iteration, so I have to change it here as well. Okay, fix this, save it, run it. Now we get it, 100th iteration. Okay, so this should be a very working program, very good working program. And I can print the difference of the from the guess from the actual root. So, but to make it more clear, but and we can do it just for you to check. Let's put different. Then we can do not this one here. But we have to bring it. But here I'm gonna put that little change has to be done. So you can see here the difference between 69, 73. The absolute value difference is about 4, 0, 1, 6, then basically 0 here. Here is very small actually. If you notice here, minus 30. Up to here, that should be, that's very small. So what we can do, look at the constraint. Here has to be greater than, okay. But once we're here, because we passed the initial, so guess we can actually put less than, and that should be actually a correct. See. Not here. There's something like less than. No, if initial guess is greater, I think that should be correct because wanna test whether it's greater. But I don't like this one here because if it is greater than, it is order means that it keep going. This if I have this here, it could keep going. So what I can do, I can get rid of this here, and then it stops. Okay. You see, it stops at the fifth iteration because this is a this is the correct program. But the reason why I add the iteration is because this case it just stops at the fifth iteration. But get it? Might be the case that it can keep going depending on what your inputs. Let me give you one example. Let's say I put, for example, my initial guess is gonna be let's say my initial guess is 7 and my root is 49. That will test whether it will keep going or not. So let's see. Save it and run it. See, it stops the first time because root approximation here. That means that got the right thing, got the right. But then this one is not guess bar. It should be in guess. That should fix that problem. 7 times 7, 49. So that is correct. So what I wanna fix is this here. But So what I have to do is, okay, so Google how to X a while Python. The way you do it is by breaking statement. Okay. So after that, okay, so after updating the while loop, the counter, so I'm gonna check if I, then I'm going, so if I is greater than 100, then we're gonna break the loop. Okay, so now change this one 4.5. Okay, so it stops at the 50th iteration. Because look, 7 times 7, 49, so it's almost very close here. Okay, but it stops at the 5th. But let's say I want to stop at the third iteration. Purpose. So what I would do is I would change, instead of 100, I would change it to 3, and that will tell us whether we have the right code or not. It stops at 3, no matter if it doesn't hit the tolerance. But I want to keep it at 100 so that way it doesn't keep going too long for too long. You can adjust that anyways by getting input from the user, or just by changing it here. This is a working program now. See, stops at the 5th iteration because we hit the tolerance. This is what I wanted to show you. The improved code. This is the main code, improved code. Or these are the variable initialization. Okay, thank you very much. Don't forget to subscribe, please.